right now we're going to talk about surface area. And what surface area is, it's the area of the surface of a three-dimensional shape or a polyhedron. So we can all identify this three-dimensional shape or polyhedron as a cube. So in order to find the surface area, the area of all of the surfaces, we need to find first the area of each individual surface. And the easiest way to do that is to think about it as a net. And what a net is that polyhedron unfolded. That polyhedron, here's my cube, unfolded so that it now is made up of individual two-dimensional shapes. And that cube, as we see, is broken down into how many different shapes? 1, 2, 3, 4, 5, 6. And all of those shapes are, you got it, squares, two-dimensional squares. So in order for us to find the surface area of a cube, this three-dimensional polyhedron, I want to break it down into a net. That's the unfolding of that three-dimensional figure. And I want to find the area of each individual shape. So we have our net. Let's use another template to find that surface area. So after we removed our net, we notice we have this. This is the outline, this is the shape, this is the template for that cube and that cube's net. So we want to find the surface area, so that means we need to find the individual areas for each shape involved. In this case, it's made very easy for us. So it's broken down into how many different shapes. This is how I suggest you do it. Keep yourself organized. Shape 1, shape 2, shape 3, shape 4, shape 5, and shape 6. These are all whats? These are all, you got it, they're all squares. How do I find the area for each square? Remember, the area formula for a square is area equals length times width. And sometimes we say base times height, but we're going to go with length times width. So do they give us the length and the width? Here they do. Here they give me the length. And if the length is 1.5, the width is going to be, if it's a square, you got it, it's going to be the same thing. So my length is 1.5, my width is going to be 1.5 as well. I'm going to label that 1.5 meters. And I want to find the area of this square. All I'm going to do is plug it into my formula, rewrite my formula. Area equals 1.5 times 1.5. Let's do the math. 1.5 times 1.5. 5 times 5 gives us 25. Carry my 2. 5 times 1 is 5. Plus 2 is 7. I'm moving over a place value. That means I need to put a 0 as that placeholder. 1 times 5 is 5, and 1 times 1 is 1. What do I do with these now? You got it. I add them. 5 plus 0 is 5. 7 plus 5 is 12. Plus 1, 2. Now, don't forget we have a decimal in this number. Remember, when we multiply decimals, we often pretend that we don't have that decimal by removing it. So we're going to move that decimal out 1 space. In this decimal, we're going to move it out 1 space. So in our product, we need to now put that decimal back in. 1 space, 2 spaces. So it would be here, and any whole number, the decimal is at the end of the number, moving it in 2 spaces. 1, 2. So now it says 2.25. 2.25 what? Meters. 2.25 meters. And remember, we're dealing with area. So we're talking about units squared. So if this is 2.25, how many is this going to be? Well, the width and the length are the same. It would be the same process. So I'm going to get 2.25 meters, and don't forget squared because we're dealing with area. And so if this is 2.25, shape number 6 is going to be 2.25 meters squared, and this is going to be, you got it, 2.25 meters squared, and this, and I think you get the picture. Number 1 is going to be 2.25 meters squared. So now I want to find the surface area for all of the, this entire polyhedron. What I'm going to do is, I'm going to multiply. I could add, I could do repeated addition, but we're in 6th grade. We can be a little more advanced than that. We're going to multiply. So I have how many shapes? 1, 2, 3, 4, 5, 6. 2 bases and 4 faces. So I have 6 shapes and they're all the same value. How do you think I'm going to find the entire surface area? If you said multiply 2.25 by 6, you were right. So we're going to multiply 2.25 by 6. So remember, we have 2 decimal spaces going on. So we're going to pretend as though it's not there. We're going to take that out and then add it into the product. 6 times 5 gives me 0, 3, 6 times 2 is 12, plus 3 is 15, 5, 1. 6 times 2 is 12, plus 1, 13. So I have 1,350, but I need to remember to put that decimal back in. How many spaces? I took it out, 1, 2. I'm going to put it back in 2 spaces. How do I know where to start? Well, in a whole number, my decimal is always at the end. I'm going to move it in 2 spaces, 1, 2. And I end up with 13.5. Because that 0, it has no value at the end. It is 13.5. So my entire surface area, SA for surface area, equals 13.5 meters. Remember, we're talking in square units because it's area, meters squared. All right, and this polyhedron right here is you got it, it's a pyramid. But what kind of a pyramid? What kind of a pyramid? So we're going to look at it. We always identify pyramids by their base. The base. And this base is what shape is that? That is a square. So this polyhedron right here is a square pyramid. Square pyramid. These are our faces. How many faces does it have? It has 1, 2, 3, 4 faces. And how many bases? It only has 1 base. Here it is sitting horizontally, parallel to the ground. And if we turn it over, this is obviously not another face. It is not a face. This is, I'm sorry, a base rather. My apologies. This is the only base that we have. So let's look at what that polyhedron looks like as a net. This is the net of that square pyramid. If we put it back together, we notice that we would get that 3-dimensional pyramid. And if we unfold it, we notice that we have our base, it is a square, and we have our faces as 1, 2, 3, 4 triangles. So now how do we find the surface area of this polyhedron, this square pyramid? Well, we do it the same way we did with that cube. We unfolded it as its net, and we're going to calculate the area of each individual shape that makes up that surface. So let's take a look at the template we have behind this and find that surface area. All right, so using this template, this was our square pyramid unfolded. And we know that the first thing we do is define how many faces or bases do we have. In other words, how many shapes do we have to find the area for? So we're going to call this first triangle, we're going to call this shape 1. We're going to call this one shape 2. We'll call this 3. We'll call this one 4. And we'll call this 5. I'm going to label it right up there. So notice that we have 5 shapes that we're going to have to find the area for. So this is where we're going to have to use a little bit of logic. We're given a few of the dimensions, and now we have to work with them to figure out, well, what is the rest going to look like? So I have 1, 2, 3, 4 triangles that are all the same. So the dimension of one triangle is going to be the dimensions of another. Let's start with this top triangle right here. So I know that in order to find the area for a triangle, I need to use my formula, which is area equals base times height divided by 2. So ask ourselves, what are we given? What do we have? We have a height of 2 inches, but do I have a base? I don't have the base. However, if you look at this square right here, or if you're thinking about it in terms of this triangle right here, I am given the base. So the base for this one is going to be the same as the base for that one. So I have my height and I have my base, which is going to be 2.2. And I'll just label that right here. I'll say that's 2.2 inches. I have everything I need to find the area now. So let's find the area of that first triangle. Use my formula, A equals, what is my base? My base is 2.2 times my height, which is 2, and I'm going to divide all of that by 2. Now, you could be thinking, if I'm multiplying by 2 and then dividing by 2, I can just cancel those 2 out and get my quotient. But we're going to actually do the math, and we'll talk about it both ways. So 2.2 times 2, let's do the math here. 2.2 times 2. 2 times 2 is 4. 2 times 2 is 4. And I had one decimal space here. When I did my multiplication, I imagined that I took it out. And now I'm going to put that back in. I took it out one space. I'm going to put it back in. I'm going to place it back in from the beginning, one space. So I end up with a product of 4.4. So that is now area equals 4.4 divided by 2. Am I done? No, I still need to do my division. So what is 4.4 divided by 2? Let's do it right here. 4.4 is my dividend and 2 is my divisor. Does 2 go into 4? It certainly does. 2 goes into 4 2 times. 2 times 2 is 4. Subtract. 4 minus 4 gives me 0. Bring down. Brought my 4 down. Does 2 go into 4? Absolutely. How many times? 2 times. 2 times 2 is 4. I end up with 0 when I do my subtraction. And now I bring my decimal up. So there we have it, 2.2. Area equals 2.2. What's my unit? Inches. And we're talking about area, so it's inches squared. So shape 2, the area for shape 2 is 2.2 inches squared. So if that's the area for shape 2, what about shape 1? Doesn't it have the same dimensions? It certainly does. So what's my area going to be? 2.2 inches squared. What about this one? If it's the same triangle with the same dimensions, 2.2 inches squared. And this one, you got it, 2.2 inches squared. So that's most of the work right there. And I really only had to do one math problem, use my knowledge of geometry and the area of a triangle to solve for 4 of these. Last one left, number 5. Number 5 is you got it, it's a square because it was a square pyramid. And we know the way to find the area of a square is length times width. So if the width is 2.2, what is my length going to be? 2.2 inches. So let's set it up. Area equals length times width. Let's plug our numbers in. Area equals 2.2 times 2.2. Let's do the math. 2.2 times 2.2. Got a little distracted there. 2.2 times 2.2. 2 times, and again, we have our decimals. We're going to pretend as though we're removing them. We're going to ignore them for the time being. And I'm removing this one place and this one place. So with my product, I'm going to put my decimal in 2 places. So 2 times 2 is 4. 2 times 2 is 4. I'm moving over a place value. I'm going to put my placeholder as a 0. 2 times 2 is 4, and 2 times 2 is 4. Let's add those up. 4 plus 0 is 4. 4 plus 4 is 8. And 4 plus nothing is 4. And we're going to put our decimal back in. We're going to start from the end because any whole number's decimal always goes at the end, whether it's written or not. And we're going to put it in 2 places. 1, 2. So we end up with 4.84. 4.84 inches squared. So this is 2.2, 2.2, 2.2, 2.2, and 4.8. So now how do I find the total surface area? I'm going to add all of these together. Now I'm going to simplify things for myself. I know that this shape 1, 2, 3, and 4, they're all triangles of the same dimension. So instead of adding this 4 times, what's a quicker way to add things multiple times? You got it, multiplication. So I'm going to multiply 2.2 times how many? 1, 2, 3, 4 to find the total area of all these triangles, times 4. Again, I have 1 decimal space. I'm going to take it out for now. 4 times 2 is 8. 4 times 2 is 8. I took my decimal out once. I'm going to start from the end of my whole number, 88, and I'm going to move it in 1 space. I have 8.8. So the surface area, or the area for all of these triangles, is 8.8 inches squared. And then I'm going to add that to my remaining shape. This would be my base. So it's going to be 8.8 plus, what was the area of that square, that base? 4.84. 4.84. And you notice when I'm adding decimals, I'm lining up the decimal. If it helps you, since there's no digit above the 4, I can put a 0. 0 plus 4 is 4. 8 plus 8 is 16. Carry my 1. 8 plus 4 is 12. Plus 1 is 13. And with addition and subtraction, I bring my decimal straight down. Always line up your decimals with addition and subtraction. I'm left with 13.64. 13.64. The surface area of my square pyramid is going to be 13.64 inches squared. And there we go. So it really doesn't matter if you have a cube, a rectangular prism, a triangular prism, a square pyramid, or a triangular pyramid, or any other kind of polyhedron. We find surface area using the same technique. The easiest way is to break it down into its net. Identify how many faces and or how many bases. In this case, we could rotate the cube any way we want and decide which 2 are going to be our bases. This would be my base in this case, and this would be another base with my faces around, or this would be my base, and these are all of my faces. Regardless, we would break it down into its individual parts and find the area of each part. The best way to do that, break it down using that net concept, and then find the area of each individual shape by labeling them to keep yourself organized, shapes 1, 2, 3, 4, 5, and 6, or however works best for you. So you can apply this to any polyhedron, and I'm sure you'll be working on this in future lessons. So I hope this was helpful.